Good afternoon, everybody, and welcome back to the iCar Tech Center. We're here today to talk a little bit more about high voltage vehicles and some of the safety aspects and things there. To my left here, we have Mr. Jeff Poole. He is the leader of our subject matter expert team in Appleton, Wisconsin. I'm Bud Center, Director of Technical Products and Curriculum. To my right here, we have Mark Allen from Audi, and he's got a really long title that I'll let the screen show you, or Mark can explain it to you here in a minute. And then at the end, we have our buddy Dirk Fuchs, who is the Director of Technical Products and Services.
Yes, sir.
So let's go ahead and get our conversation started. You know, Mark, we all know that you're one of the foremost experts in the industry on high voltage vehicles and all things EV. And let's talk a little bit about the safety side of this and some of the things that, you know, technicians need to understand and shops need to understand. What are the things that they need to do to make themselves ready to handle these electric vehicles?
You know, great points. I think realistically, we were talking before we got on air, and if you think about it, it's changing behaviors. If we were going to release an ICE engine vehicle in this time period, as opposed to the end of the 1800s, we would be facing a lot of the same challenges in terms of developing behaviors for safety, handling fuel and 12-volt batteries and so forth. So we are giving you a lot of warnings and making you aware of things, but that's to help you with your safety and your planning. So keep that in mind. Realistically, you'll never see a seasoned EV tech, HVT or EFK, with jewelry or piercings or things of that nature, right? We have to keep instilling that into ourselves. So new technology, really exciting time to be in the business for all of us, I feel. But we just have to proceed with some caution and understand what we're dealing with first.
Perfect. So before we get started here, I want to remind everybody that if you have questions throughout this broadcast, you can do one of two things. You can enter them into the chat on your screen, and the questions will come up and we'll get those answered for you. If there are questions you have after this broadcast is finished, you can submit them to repairersrealm@i-car.com, and we'll get those questions answered for you. So, Mr. Fuchs.
Yes, sir.
So we start talking about all these things that shops need to understand,
Yeah.
some of their safety things. And you and I are out talking about these kind of things constantly.
Yeah.
But what are some of the things that shops really need to keep in the forefront of their mind? What do they need to think about as that vehicle's coming into their shop? Mm-hmm. You know, what do they need to look at?
You know, the space requirements would be one of the most important things to me. Not like, okay, when I would be now a technician, and I would like think, why he talks about space? It's a vehicle and I need a lift and I can tackle everything what I have to do. Yeah, but when we really approaching the high voltage system, we need really much more distance to other workplaces in the workshop in regards to dust and dirt and all the particles what flying around. And you know my spiel about milliohm. I think everybody laughs of course, when I'm talking about milliohm, and I don't know you folks out there if you ever heard of my speech. We have to learn dealing with completely new resistance value. And you know, usually we were used to, and I take this cable here a little bit in my hand and say, okay, I measure this, it's 1 ohm resistance, okay, it's fine, and it works. Back in the days you had your test slide and you check things. Those times are over. We have to really verify resistance values, bonding values, and all those things. So not only the space is really important, also the understanding, and now we are in the part of training. So I want to come back. I think I want to give the word back then to Jeff and to Mark a little bit, also see it from an Audi perspective. And what I want to do a little bit later, go back and revise this conversation and want to show you something. I don't know if the camera can show you what we have here. I have here a little high voltage testing or training card what I wanted to bring in. So you will see it later. Oh yeah, there it is. Thank you guys for putting this up. So I want to go later and make a little make a little show around this card and give you guys a little bit more knowledge. But now I think I want to listen from Mark and from Jeff Poole. And you know, I love Audi. You know, you guys know I'm German, so.
You've got a really valid point with the milliohms, and I'm not going to belabor that too much more. But the reality is, in the past, where we had a vehicle in a collision shop and we did some work on it, and maybe we didn't get a good ground connection someplace, and that created some electrical issues. But it wasn't necessarily catastrophic in nature. Once we resolved that, you know, you get that high resistance connection in a low voltage system, and you hit the starter, and basically the lights go dim, and or whatever the situation is, and it's like, okay, but where we're dealing with this here, and the dust in the body shop environment becomes a really critical piece with those higher voltages, because now every one of those connectors turns into a heating element that isn't designed to be a heating element.
Absolutely.
And that's bad news down the road.
Maybe we tackle that directly, huh? What do you think? You want me to go? No, I get up, guys. Let's do this now before we go back to Mark and listen a little bit to Audi. So what I jumped off, and I think everybody is like, holy hell, what is Dirk doing here? So when I remove, for example, a connector, and the typical situation in a shop environment is like, oh yeah, I can disconnect some stuff. Of course, the vehicle is safe, everything is good. I would work high voltage gloves.
Yes,
Mark, so PPE.
always tried PPE.
Yeah, so, but you know, we have here a training model, and only to give you guys an example, and what Jeff Poole just said is exactly spot on. So those connectors are usually have a resistance here of 1 milliohm. That's a target resistance. We want to be below 1 milliohm. 1 milliohm.
Thousandth of an ohm.
Thousandth of an ohm. 0.001 ohm. Can you measure that with a multimeter? No, you can't. So new measurement devices is necessary. But the point what Jeff made is they're going particulars of dust, dirt, overspray, stuff in these connectors. The situation will change, that 1 milliohm change in 10 or in 20 milliohm really rapidly, and you can't even see in a connector that you have to high resistance. And that makes out of maybe 80, 90 watts what go over, and I have a famous calculation for this. So watts goes over it, so the electrical power, and 80, 90 watts is like a light bulb. This is regularly full throttle, 300 amps going over a system, and then we have 80, 90 watts. When it's 10 milliohm, it's 800 watts. It's 20 milliohm, it's 1,800 watts, and so on, and so on, and so on. And that brings heat to those elements, and that's the risk that vehicles may be burning down on the hard shoulder when a customer just took the car from the shop. So this is important, that we have the cleanliness, that we have the space, that nothing comes in. And to really make sure nothing comes here in, we do one thing. We cover those connectors. So we have here really nice 3D printed connectors, and let me hold it a little bit down, and we cover them. Then when I want to replace, in this case, this DC-DC converter, that takes maybe a while that my part comes back. It takes a while that I can go back in the repair procedure, and parts and cars standing around. So we need to protect our connectors. That's really, really important. So that was the part what I wanted to show here, and I would love to go back and talk a little bit more about Audi.
Excellent, excellent. So thank you for having me here today, and thank you to everyone out there for tuning in, so to speak, and listening to us. I did this deck back in 2016 as the original of this. And at the time, I thought, oh, you know, a little bit of a Clint Eastwood moment. You know, you think you're a rebel living in the moment. And then I said, well, the moment has already passed and it's history, right? So you're not a rebel ever because you live in the moment. And the future is here. Well, it was kind of a prophecy to myself because this is already so past, it's no longer new. But it is still a new topic in the automotive industry, in the collision repair industry, and it's evolving. So what happens here may change in relevance as we go forward. And knowledge has relevance. It doesn't have an expiration date, but it has relevance. So kind of keep that in mind. We're going to talk about some of the things from the Audi perspective that kind of build to a general perspective. So keep that in mind as well. We're not going to teach you how to go into the battery today. We're not going to suit up. Dirk pointed out very well that he was not wearing PPE because that's a powered down scenario and it's demonstration purposes. So we'll make that point again. There's a time that you need to have that. Okay, so 2017 we did the world reveal, or 2018 rather, the world reveal of the Audi e-tron and e-tron Sportback, and it was our first world premiere that we had in the United States for Audi. So we had dignitaries and dealers and so forth from around the globe in San Francisco, and it was an amazing night. I just can't even begin to tell you in a very short time. But we let the car out and we proclaimed that Audi hasn't gone electric, electric has gone Audi. And a little braggadocio, but I think when you see the quality of the vehicles and the difference between maybe some of the competitors and what we do, yeah, range is one thing, but comfort and quality are totally another. So kind of keep that in the mind as well. So before a vehicle comes to market and we have to do a lot of logistics. I mean, there are parts concerns in having all the parts available. There's the whole tour, the glitz and glamour of advertising and so forth. But what we do from a collision standpoint is we want to reassure the customer that they're in a 5-star crash rated vehicle, highest rating. So we crash test our cars. We do it at IIHS, but before we do, and this is a full frontal, side impact, offset impact at IIHS, we go and we do crash testing at NCAP, and we make sure before we go through when we bring the cars to IIHS. So these are actually NCAP cars that are at our training facility in Ashburn, Virginia. And then we have the red one that you'll see coming up in Eastvale, California. So this is a side impact test, and you'll see that the structure held very well, protected our customer, but there's no damage to the battery. There's a trim piece that fell down, but that's a trim piece. Battery is fine. These vehicles were able to drive onto the tow truck and have them delivered to the training center, and they drove as normal. Obviously, we would want to repair this vehicle, but there you go. Here you go. Some of the things that we need to be aware of, and something you need to be aware of is collision repairers or insurance adjusters. And that's, as we all have been told by our parents and told our children as parents, look with your eyes and not with your hands. Put your hands in your pockets if you're unsure of the state, because we think of the battery, but Dirk's cart over here has a lot of other componentry that has high voltage in it. And if I'm an adjuster and I don't know the state of health and I raise the hood, I look with my eyes and not with my hands, and we go ahead. What's in that area that you should be concerned with? Well, we have AC to DC converters, or DC to AC converters. We have our battery controllers. We have all high voltage cabling. We have heating and air conditioning. That's all run from high voltage. And in upcoming Audis, there will be a thermal management system that uses refrigerant to cool not only the drives for the Quattro system, but also the battery. So these are things that we need to be aware of. And again, we don't need to be afraid. There are some good indicators that we have in the dashboard as required by NHTSA that we'll see a little bit later in the presentation. Give you the structure of the e-tron. You can see it's very, very robust. The battery is not part of the structure of the vehicle, meaning if I took the battery out, the vehicle wouldn't twist or whatever. It's very robust. So you can see in the underlying areas of the floor, the cross members are all ultra advanced high strength steel and are super, super tough, super rigid. Same thing with your B pillar. It's multiple layers of different steels. So really great thing. If you notice the battery case in that smaller picture on the left shows you the aluminum extrusion that surrounds the battery. Now that's structure for the battery, but it also adds additional crash worthiness into the vehicle. So if you look back at these side impacts here, it hasn't even gotten to the battery. So it's a tremendous hit. So what does it look like with the body off and the drive system? This is kind of the glamour shot. We had these mock-ups set up in San Francisco. You have your drive motor and rear suspension in the back. Kind of looks in some respects like a conventional rear-wheel drive suspension unit with your airmatic suspension in it. A battery that is the size of queen-size mattress and weighs almost 1,700 pounds. So if this has to come out of the car or it has to get unpacked from a truck, well, we're not going to get a couple of guys and do the old, oh, let's pick it up and bring it in, right? Or we'll all get underneath it, gas monkey style, and we'll just let it down. It's not going to happen. There are special tools and training and equipment that go along with it. And we'll get into some of that as well.
Mark, can I ask a question? When I saw the side impact, it just came in my mind. When you go back to this picture and you see the side impact, when so a technician or a workshop would get a vehicle like this in, and you said, yeah, the battery didn't really got anything, but is there any repair procedure from Audi where you say, hey, we have to test batteries for micro cracks, that cooling system is not leaking and stuff like that? Is there any definition for that there, or how you guys handle this?
That is a great question. So the first indicator, and we'll look at that a little bit later, right? But if you look at the dashboard, if there's no warning lights for the battery, then system is good, car can drive. There'll be one warning light that'll indicate that there is a potential problem with the high voltage system. Mm-hmm. So I can look again from the other side with not using my hands too much, and system is fine. We need to address it. We need to run guided fault finding on the battery and on the HV system. And the car will still drive. If there are two lights, your big thing is the vehicle will not drive.
Yeah.
Right? And then there's a potential for a grounding issue or bonding issue, as we talk about so often. You've done some really great stuff with that. So you're okay to go up to this car. It's not to be afraid of it, right? But we always want to proceed with caution so that we know we're okay. If you're going to have the typical parking lot bump and the customer comes in, there's no lights, we're good, right? In this repair scenario, you're more than likely going to remove the battery and de-energize it. And in that guided fault finding of shutdown, of both 12-volt system, and we have to keep talking about 12 volts because that's still very important, and that high voltage system. Then we will go through, we can see general health, check the whole system general health, and we can see temperatures of each individual cell packet in each module, and we can also see what the state of charge is in each cell packet in each module. And it'll tell you in that guided fault finding, well, it's module 8, so you just have to look at the mapping of where that is in the battery, right? So great stuff. Again, you know what, we would be looking for fuel leaks or if there were indications and so like that, right? So excellent.
With fuel, we can smell it. With electricity, you're not necessarily going to smell it.
Yeah.
You don't want to touch it accidentally.
Yeah, for sure.
Does, while they're in there and the car's in the shop, does Audi recommend any type of battery monitoring while the vehicles, we hear about folks that have issues with, batteries that initially are fine and then they have a problem later. Is there any kind of battery monitoring requirements?
And it depends on whether you're de-energizing the battery or not. In general, if you're just doing light repairs and you don't need to, say, take the fender off where the plug is, which is high voltage, no, it should be fine. But if it's a heavy hit like this, it may be worth monitoring that because simple hit with a heat gun to see and just check across, and as long as everything is about the same temperature, you're okay.
So thermal camera or a thermal temperature.
Correct, right. Again, change in behaviors that we don't normally think of in the ICE world, right? So, all right, so.
So I see we're getting a lot of questions already. Would you prefer that we wait until the end or address them as they come in? I don't want to interrupt your flow.
That's a great question. Well, you know what? This is for the audience, right?
Okay.
So let's see.
So if we scroll back up, Tony, I think the first question we got was about if the person forgets and they wear jewelry, essentially what's the risk? And I know that I think back to my days as a tech, and I used to do stupid things. At the time it wasn't done, but I would put tools in my pocket. Now, if you do that and you lean over the vehicle, you could have a problem.
Yeah.
And if you've got a necklace or anything that comes in contact with any of this high voltage stuff, you're going to have a really bad day.
Yeah, there are a lot of considerations. So it's not just jewelry. You're correct. Tools. When I was married, I had my wedding ring on, working on a 12-volt system, and my eldest daughter came out the front door, and she looked like she was running towards the street. And to get to her, I arced the wedding ring between the pole on the distributor and on the cylinder head. And boy, I still have the scar to this day, though the wedding ring is long gone. So, it's behaviors that you need to be aware of. And even if you are wearing the PPE, that ring should come off, the piercings come out. Other things to consider are, do you have medical implanted devices? We were talking with Michael Lestuca from State Farm, and he had some implant surgery done. He now is not qualified to work on high voltage vehicles because there is a potential risk. There are heart pumps, insulin pumps, things of that nature that you need to be aware of.
To that point, PPE is important. Verification is more important. We have to know and we have to learn what we're doing, what we measure, what we test. As an example, we're going through a repair procedure. We want to disconnect a battery, and we have to take out the battery maybe. So I will verify first that my battery, that housing, what I potentially touch, also with PPE, has no potential on. The problem is, as long our bonding straps and it's bonded to the chassis, I'm pretty safe. I take the bonding straps off, remove the battery, there is an isolation fold in the battery, I'm the bonding strap. Do I have PPE on? Hell yeah, when not, I'm dead. So then have a jewelry around that thing, what you always describe. It bounces back and forth, it hits the casing of the battery with an insulation fold. That's it, game over. So first of all, verifying, that scenario what I just described is a scenario what is for, in my opinion, for a regular technician anyway a no-go. When you realize there is a fold, this is working under live conditions. And I think you educating your technicians even to this step that every dealership or any area has those specified high voltage technicians who are allowed and educated working under live conditions. This is correct,
Yes,
right?
yeah, out of 315, we have 310 dealers that have a high voltage expert trained in battery, and then they're backed by high voltage technicians that can do diagnostics but not go into the high voltage system.
Mm-hmm.
So it was a lot of logistics to bring this vehicle to market and have everyone trained to do that. With that being said, having the grand opportunity to be a multiplication factor as a trainer, we gave train the trainer courses, and very, very talented mechanical trainers, electrical diagnostic technicians, and I'm walking around going, take that out, take that off. We had to go through just to remind them.
Yeah.
So, you know what? We all think we're very special, and we are, but use common sense.
Right.
Electricity
I mean, I
doesn't
think-
discriminate.
Yeah.
Right.
And
I
it
think
will
part
bite
of-
you if you give it a chance.
We always
I
say,
think-
sorry, Bud,
I
go
think
ahead.
part of the common
Yeah.
sense too is the conversation you and I were having yesterday
Yeah.
about when you're wearing all the PPE and you're reaching for something, make sure that you're thinking about you're not leaning against something that doesn't have protection,
Yeah.
right?
Yes.
If you've got protection on your hands, but you lean against something,
Yeah,
it's still going to be a bad day.
absolutely.
And even if you wear the 20-calorie suit as we prescribe, well, you sweat a lot. And guess what? It now becomes conductive. So in an area where you may wind up doing a lot of battery rebuilding or high voltage system work, you want to have more than one suit because you're going to get hot and you're going to sweat, right? So again, stuff to consider. It's different, but it's not scary.
I can
right?
bet you there's probably some folks out in the collision industry that can relate to the hot summertime in the shop. You're a technician, you're welding, you've got your leathers on, you've got your welding jacket on, you're drenched in sweat, and the spatter accumulated in the contact tip between that and the shielding gas nozzle, and maybe they're guiding the shielding gas nozzle and they get just a little bit of a shock, and that's only 26, 30 volts open circuit.
Right.
But you'll get a little twinge out of that. It's like, whoa, what happened there?
Yeah.
And that's just very low voltage. Translate that to high voltage and bad things happen.
Yep.
Yeah.
Yep.
So question number 2, I think we can answer without even asking Mark the question because I've heard all of his comments about PPE, but the question was, does Audi prescribe PPE worldwide or only in the US?
Worldwide. Worldwide.
I think we all knew the answer to that one before we got started. The next question sounds like something that Jeff Poole would like to actually test. And the question is, what would be worse, an erupted battery or a punctured battery during a collision?
I'm not sure how to interpret erupted versus punctured. We have done some puncture tests on batteries, and they get a lot of excitement happens very, very quickly as the internal chemistry and things react.
These are some of the things that I've talked about where I'll be on the road somewhere and I'll get a video and I say, wait a minute, where did we do that?
The puncture rig is right down there. We did it outside. Anyway, so the liquid part of it, if you're getting liquid out of these batteries, you must be really compressing them hard because it's more of a paste-like material that's in the batteries. So it's not like the acid that's in a typical lead acid battery that you spill it and it's going to run all over the place. There had to be some catastrophic damage to the vehicle to actually violate those cells and then open them up. At that point in time, though, when those cells are violated, bad things happen pretty much spontaneously at the point of the accident. Unfortunately, sometimes there's a delayed reaction too, where maybe after first responders have put out the initial fire, because of compromises in there, there's kind of a delay that things are kind of slow to react, and there can be some delayed thermal events that happen in those cases. Again, you've got catastrophic damage to that vehicle, though, at that point in time.
Yeah, and that realistically is a vehicle that would need to go to a tow yard that has a quarantine area where it's away from the other vehicles and can be monitored. The tow company, the yard should notify their local fire company and so forth, so that they have the equipment ready and available if needed, and to watch the vehicle. So
Great.
to the liquid, most of that is coolant. Believe it or not, yes, we cool the batteries, and we've had a couple instances where in the e-tron and newer batteries, the chill plate is external to the battery. So you potentially could get a leak and not have the battery damaged, since it's underneath the battery, between the battery and a skid plate, right? So a chunk of metal comes up off the roadbed or something and does that. So
Great.
good questions, thanks.
So the next one's definitely a question from Mark, because it's a question about the life expectancy on an e-tron battery, and is there something that a consumer can do to influence the life of the battery?
Yeah, I mean, these are all real world proof cases that are coming out right now. We have an 80,000 mile warranty on the battery, but that doesn't mean that that's the end of the useful life. And it also depends on, okay, Bud, am I using the 300 amp
Right.
supercharger, or are we using the level 2 charger in our home where we're charging at different rates? The amount of charge puts different amount of heat and energy into the battery and into the plugs, and it makes it go. We really haven't seen, what is the end life of that battery yet. So it's some pretty good news for the near future. I think more stuff will develop on that as we get along.
Great.
Only
So-
L2, L3 charge. I want to tell that story. That was pretty interesting. I had meetings with in Colorado with the Department of Transportation, and they were saying me that one of the rental car companies want to put on the Denver airport 50 supercharging stations in. That's a lot for the infrastructure of the whole airport and the people who live around that airport. Yep. So 50 superchargers are equal to 20% of the whole electricity consumption of Denver International Airport, only to give you that as a little hint what we're talking here.
Yeah.
So you had the supercharger experience yesterday.
I did,
So,
but we don't have to go into that now.
No.
But so our next question is a follow-up on Dirk's point about tools, and it's asking, is there an end-of-line tester for an HV battery unit? So it's, I think, looking for recommendations for tools.
I can only tell you from the Audi and Volkswagen side, we do have specified tools, and we can share that list out for what you need. The tools go beyond, the ratchets and so forth, and they're all very special ratchets and hand tools that are insulated with silicone so that you don't cause an arc when working on a high voltage system. Those are kind of a more common sort of thing, but when you get into testers, there are non-name brand or non-specific testers, and then there are specified ones by manufacturers. I think know what you're working on.
Mark, you made actually to the beginning already a point where you said, okay, go in fault finding. And this is Audi and Volkswagen's Diagnostic tool, where you have a fault finding program and go through this procedure. And you're ending up and can see, you said it as well, battery cell values and temperature. And this is something what we have to address. It's so important that we learning now the OE diagnostic tool is so important for this
Yes.
this work, that you have a chance and see this data. When a car would come in with a wreck, the pictures what you showed me, the first thing what I would do as a shop, I would say, I take my diagnostic tool, I plug it in, I want to see the battery temperature and cell values. Balancing is so important that every cell is on the same level. Is there a cell difference? Resistance occurs, resistance causes temperature, and temperature can have severe consequences. So diagnostic tools in the future, or we are in the future,
Yes.
you want to work on those vehicles, you need access to manufacturer software and manufacturer
No, we're
diagnostic
actually
tool.
in the past.
Behind the past.
You know,
Okay.
we're in the past. So,
Alright.
yeah, I mean, those are great points. And the connectors, whether it's cabling or dongles that can communicate to the battery when it's out of the vehicle, which is kind of cool. They all have to be super high voltage rated. Yeah, we tested some and they didn't do so well. They kind of got a little hot and stopped communicating. This is where, you know what you're working on, know what the requirements are before you go and do this. And that's why we're saying we're not teaching you how to repair these right
That's
now,
right.
right?
That's right.
This is a major investment, and in technology, equipment, but then training. So
Fantastic.
great stuff.
So our next question, my Audi is
I
not in
think Ted's
sync
missing an O. Audio.
Oh.
It's not in sync with video.
even after refreshing, so I don't know what that
Ah.
is. So
Okay.
we
don't
probably
think
need
that
to
was an
skip
Audi.
that one. And then they want to know, can you give a bit more information on the 20 cal PPE suit?
So it is not an insulator. It is to absorb energy in the case of a high energy flash. So they come in 5 cal, 10, 15, 20, and so forth. 20 cal is a very, very heavy suit. If you don't mind, I will go ahead in the
Absolutely.
presentation. I think since we're getting some of these questions, it would be most appropriate to show it to you. Here we go. There you go. So there's the specialized tools that are insulated. They come in a very professional looking briefcase sort of an affair. And you'll wind up chasing those all around your shop for sure, because, you know, they're basically 3/8, half-inch, and quarter-inch socket sets that somebody will grab to take a bumper cover off if they can't find it. But that handsome bunch of fellows there are properly attired. Mine is a 10 cal suit, and if most of you can see me now, you'll see why my visor is down. I really have a face for visor down. My colleague there in that tan colored suit is a 20 cal suit, and that's to protect you from the arc flashing and burning you.
So real quick, whenever I look at a picture like that and I think, wow, these guys are really protected to the nth degree, you know, I think it's really critical to go in with the mindset of nobody gets up in the morning expecting to have a bad day. And they're prepared that if something does catastrophically go wrong, they do have a bad day, they still go home from it, hopefully with no injuries.
Right.
You know, that's the key of the mindset is, you know, how many mistakes are you away from being dead or injured severely?
Yep.
And you want to put as many roadblocks, you want to mistake-proof yourself to the best of your ability, and having the right tools, equipment, and training position you there.
I'll go another step, and I'll date myself. Back when I was driving a race car, it required the Nomex suit, but they didn't require Nomex underwear. Well, to me, having had a family friend burn to death at Indianapolis, fire is not something that I disrespect. I won't say that I'm afraid of it, but I don't like it. So the other drivers would always tease me. It's like, why are you wearing a double layer underwear and then a 3-layer suit and everything else? And I would just always say Eddie Sachs. I don't want to be Eddie Sachs. So you plan for the worst, expect the best out of it, and I think that's what we're trying to say here.
Great. Looks like we have a question about where to get the procedures. It's is the only guidance we should use when de-energizing the vehicle prior to a repair come from the Irwin shop manual?
So right now I'm going to tell you, do not do the de-energization yourself. You're not trained. Have the dealer, high voltage expert and technician do the de-energization. The technician can actually run the plan and do the de-energization. That's a hard one to get out multiple times. De-energization at the dealer. Be safe. You don't have the tools and you don't have the test plan. But to answer the question of, is the information there? It absolutely is in Irwin, but it's also in the Otis OE software testing, and that's where you would find it.
Perfect. Well, I think we're finally caught up with questions and ready to go back to your presentation if we haven't
Great.
thrown you off too far.
Great stuff, you know, that's one thing. We can be adaptable here. And we're not too far off. So I'm going to restart here. And basically there are 4 levels of high voltage classification. One, if you're on the Audi program, your shop has had to take this, and that's high voltage aware. That's a requirement in Europe, and Dirk, you've talked to this a bunch of times. Even the receptionist has to have that
Yep.
so that they know it's a high voltage vehicle, and it doesn't qualify them to do any work, but it is the beginning of the communication throughout the beehive, if you will, of, hey, high voltage vehicle coming in. High voltage technician is now a electrical diagnostic technician that has received the training to run the test plans, as you were saying, in Otis, and using the software and the appropriate cabling to go into the systems, check and see, okay, do we have the appropriate temperatures in the batteries? Do we have the appropriate voltages? Do we have isolation tests that's appropriate? And they can go to the point where you're going to go into the high voltage. So at that point where I need to start donning my PPE. The high voltage expert is the person who gets to wear those really cool suits and then go into the battery and do repairs inside the battery, inside the high voltage AC system, inside the battery controller, and so forth. Anything that's high voltage at that point. The one that we didn't put here because it is Dirk Fuchs is EFK, right? So EFK is a month-long training where the technician has gone through the first 3 steps, but now we really get into the theory of electricity and how to diagnose, but not only how to diagnose, to be able to diagnose without the OE software and test plans. So this is going to be the person that, you know, if you have a bunch of batteries that roll off a train car or something, can go out and make some determinations quickly and then triage the scenario. So back to our discussions about conductivity. Mr. Milio,
Mr. Milio.
take it away, my friend.
Oh yeah, okay, so usually your body resistance, that's what that chart is showing you is, yeah, I say always from the hand to the foot, you have an average of 1,000 ohm resistance. So when you know, okay, 1,000 ohm, we're talking about Ohm's law, and we know the outlet, what I'm eyeballing here over, has 110 volts, then I know, okay, Ohm's law, volt, resistance means we talk about 110 milliamps current. when I would be touching here this cable. So I'm doing my electrical stuff at home most likely by myself, and I'm doing stupid mistakes. So a few times, it didn't hurt. It didn't. No, it hurt, but it didn't kill me. Then 110 milliamps was the average current what flowing through my body in this moment. So number one message: volt is not killing you. Current is killing you. So number two, the time, how long I would be hanging on this power source with 110 amps. 110 amps can kill me, 110 milliamps, I'm sorry, but it takes approximately 5 seconds to hold on. Then my muscles will start cramping and will not let go. So holding 5 seconds, 110 milliamps is most unlikely, then you will let go. So, but when we're going in a higher voltage / current draw, and we say we're going into 350 milliamps, we are in an area where it takes a milliseconds, my muscles start cramping, I can't let go. After 500 milliseconds, my blood will start boiling, my heart will start doing weird things, and I'm dead. So 350 milliamps, half a second, I'm sorry, guys, that's it.
And we put this graphic up for you because, to your point, it's not voltage. Average module is somewhere between 45 and 60 volts, but it's
Good
the
that
average.
It's good that you have the graphic. When you see the lower line is current, is milliamps, starts at 0 milliamps, and we go over where you see that yellow area. That's the dangerous area where your muscles cramping and you can't let go. So when you go on the other side, the timeline up to 500 milliseconds, and you see 350 milliamps go up half a second, you are in this red line, what is definitely a death sentence. So we want to tell you guys, we're dealing with extremely dangerous voltage levels, and voltage body resistance is current, what I just tried to explain. So the bad news is you make a mistake, it can have severe consequences. The good news is Jeff and I, we researching everything in this industry and electric vehicles, and every time we come to the same conclusion, we say, they are pretty safe. And so now I want to approach it a little bit from a different way. What manufacturers like Audi or whatever manufacturer you're pointing out, putting in on safety redundancies and make those vehicles safe that those accidents can't occur, this is really impressive, and this is great engineering.
Yes, this is. So we have to start transitioning, and there's 2 points I want to make. Start transitioning from the classic 12 volt that you were talking about, Jeff, right? Though it's still very important in this world, right? The 12 volt system is super important. This is more an electrical system like an aircraft. And I did my last trip in Germany, in Ingolstadt, and we got rerouted out of Munich. Instead of going to New York the way we wanted, we had to go out through Schiphol in Amsterdam. And we took off, and there was the brightest light I had ever seen. And that instinct from a child where you go 1001, 1000, and boom, the aircraft was hit by lightning.
Wow. Okay.
Right? We flew all the way back. There were no fault issues. We have systems like this that are more like an aircraft than they are a 12 volt system. The other thing I'd like to point out that Derek was talking about, he was pointing to the 110 outlet, and that's AC. In this chart that we have, you have to know AC or DC.
Yep.
So if it's going into the motor or the controller, it could be both. So you want to know when you're working on the vehicle what current you were dealing with, because when the first responders come and the doctors, they know how to treat your symptoms. and they're uniquely different. One will, as Dirk say, boil your blood and potentially shoot your eyes across the room. The other will fry your nervous system. And you might look fine today, but about 3 days from now, the limb will ossify and look like a mummy. So things, again, different. Behavioral changes.
When you look in, we right now following more the European regulations than there is no other regulations in the world. And the regulation in Europe says 30-volt AC or 60-volt DC is considered high voltage. And this is exactly the reason. AC is much more dangerous for the human body. Then we talk about an alternating current. So when you have something, your heart is, what is my heart pumping maybe now at, I don't know, 60 beats per minute? And I get exposed to DC, it's not that dangerous as when I would have the same voltage level and I run into AC, then that can trigger my heart rhythm completely and kick that off. Right. So that's always the biggest deal, AC versus DC, but only for your awareness.
So cool. This is really great stuff. We have in Irwin taken into account a lot of the collision scenarios and tell a little chart, and all you have to do is look it up. Right? So I'll do the plug now, right? You can reach out to iCar and they can look. The other place is OEM One Stop, where all the manufacturers put the links to their specific brands and their repair procedures. But we have a chart that says, okay, you need to de-energize or you don't need to de-energize, or if you're going to paint the vehicle, you need to be aware of the booth temperature and time that the vehicle sits in the booth. So these are things to take into consideration. High voltage systems, there's 3 safety rules that you'll see, and that's de-energize the vehicle. Can't get electrocuted if there's no electricity there. Secure the system against restarting. What does that mean? You put locks onto the pilot line. You disconnect and cover, and then we can prevent people from restarting the system. Because don't forget, the 12-volt system is what starts the high voltage system.
Yep.
Right? So somebody could have it partially disassembled, someone else goes in and hits the remote start or something of that nature, and all of a sudden we're starting up. And then the most important part that Dirk mentioned earlier is checking that there's no voltage present and that we have proper grounding in our isolation. So this is key. So there's a couple ways to de-energize, and that can happen at the scene of the accident, or it could happen in the shop. We do produce sheets for first responders, and we have them out there online so that if they come up on a scene and feel that they should take and de-energize the battery so that they feel safe, they have instructions there. We also have instructions in the shop, and there's a couple ways that you can do it. You can take that little pilot line, which is a small low tension internal ground, and we just pull that connector out and it opens up. But here's something I think people don't realize, Dirk, is when we pull that pilot line, it's not like pulling the plug out of the wall.
Yep.
Right? That line then allows the capacitors to open, and there'll be a bleed down time of energy. So kind of like an ignition coil bleeding down in energy, right? So it's not instantaneous, I guess is what I'm saying here.
So what they're doing is also they open the contactors in the battery that nothing comes out, and then, as you just mentioned, the capacitor will discharge over time. There's always a resistor parallel to the capacitor, and the resistor is calculated usually right now around 5 minutes. That's their discharge time when an active discharge would not present, but this is a different story. That's things what you have to learn in training classes, and but different story. So the 5 minutes is right now, I think, the guidance for the industry a little bit, but don't say, hey, Dirk said 5 minutes is what I have to wait. No, you have to look up the vehicle manufacturer service informations. Then there are still systems out there. They have, for example, 20 minutes of wait time or a different time. So always check the manufacturer information, what is really important here.
Yes, and that's, again, know what you're working on, right? We can't just go on instinct anymore. So, and then there's the guided fault finding shutdown that we talked about, and that's for the high voltage battery, but also, again, for that 12-volt battery, because that drives so many different systems.
So with Audi is also interesting. You had, when the Q5 hybrid came out with the high voltage battery, there was a battery disconnect in the bag. We have a battery disconnect on our card as well. So you pull really a big disconnect what separates the battery cells from each other. So you create an open circuit. And the other systems going into the low voltage, what you just show in the picture. So you see when you go on Mark's slides, please, you can see his low voltage disconnect, what you call a pilot line or interlock. There are different names out there. So when you disconnect this, that opens up the battery contactors. So I personally love to see a battery disconnect, means the big one what I separate and really disconnect the battery physically. That gives me personally always a better feeling, but I know the technology moved on, and a lot of service disconnect, that's how I call them, low voltage disconnects are present at a lot of manufacturers actually.
Yeah, and if you're looking at the screen, that service disconnect that you see with a little padlock, I mean, being technicians, you look at the lock and go, that wouldn't stop anybody, but it's at least a visual warning that, okay, that you have it disconnected.
Mark, especially when the key is in.
I know, you're right. And then for the first responders, they can also pull that main fuse that's at the other end of the line of that pilot line. That'll open those up. So that's definitely something. All right, here's the first responders guide that we publish out, and it gives you the locations and so forth. Also notes where you should and shouldn't cut the vehicle. So we really try and be. Remember when we were talking about earlier coming up on a vehicle and you're going to be an estimator and, you know, hands in the pockets? Well, these are some of the components that are high voltage that you need to be aware of. Just keep your hands away. I mean, there's really no need. That's why they make a thing called a supplement, right? I mean, better we be safe than compromised. So I'll give you a view of this mattress-sized battery. You know, Dirk, you said the Q5, the original Q5 hybrid, nickel metal hydride battery, but it had the pyrotechnics and fuses inside the battery, and it was not a rebuildable battery. So we pushed very hard worldwide to have a rebuildable battery, and that control junction box that has those fuses in it and the capacitors resides on top of the battery. So effectively in the transmission tunnel of what we would call in the structure of an ICE car, right? So it's separate. You would have to drop the battery, but you wouldn't have to take the battery apart, okay? So 36 modules, a lot of cells in there. So here again, the connectors are very, very safe. They're very, very small and frustrating to work with insulated tools and 3 pairs of gloves and a flash protective helmet and everything. But it's kind of like re-ringing an engine, right? I mean, it's kind of the same complexity. You're going to do measurements and values and go ahead and your preparation and so forth. So things to be aware of. There are other lithium-ion batteries in the cars, and those are mild hybrids in the Volkswagen Audi line that are 48 volt. And then we also have lithium-ion 12-volt batteries. And we're bringing that up because in the recycling, they're not going to be the ones at your local interstate battery or whatever going to pick it up, right? They really don't want those because of the way they reclaim the materials from them. Those really need to go off to a lithium-ion or lithium iron recycler that can take and handle those batteries in an appropriate way. So here's just a view of some of the connectors, and Dirk was showing you the covers. We do, in our parts offerings, offer covers for that, so they get ordered with the job in the kit, and you go ahead and do that. It would be very hard to cause an arc between the two, but when you were talking about getting dust and so forth and in there, I could actually see someone taking a non-shielded screwdriver or something and going in there, and then all of a sudden, oh boy, we have 400 volts or whatever the system is that they're working on. So we need to be aware of that. Again, that great kit of stuff. You see you're also standing on an anti-static, anti-electricity mat, and there is a hydraulic lift table. And we'll give you a little bit better view of that in a couple minutes here. Here's the internal faults that we were talking about, and these will show up in your dashboard. The one fault, it can be an internal short, but we're safe, right? We can touch the battery, we're all good. When we have two and the car doesn't move, well, now we have to have concern. And really this is where, let the pros handle it. You know, until the infrastructure of aftermarket rebuilders and technicians on these batteries builds itself up, let the people who are trained do it. It's just not worth it. It really isn't. We were talking a little bit earlier about those repair manuals and stuff. Well, here you go. Proof in the pudding, we put it out there for you. There's a lot more, so you have to look it up. One of the things that we didn't talk about is in the workspace, how do we know that the vehicle is low voltage and that it's locked? Well, realistically, we should cordon the area off with caution tape, and we have some nice little placards that we have. They're internationally recognized, so iCar has them printable. We have this in the kits that we send to the dealers for repair, and it lets you know that there is a high voltage scenario in the work bay and you should stay away, or the vehicle is de-energized and it's safe. Whatever the scenario, it should be respected within the workplace. So, Bud, we were talking a little bit earlier about what that workspace should look like, and I think this is maybe where we kind of transition to, okay, how does this fit into my shop and into my world?
Right.
So our recommendation is 16 feet in front of the car, 16 feet behind the car, 16 feet on either side. This is the most safe area that you can work in. And yeah, it's going to eat up a lot of shop space, but again, it's worker safety. When you take that battery out of the vehicle, you're going to need to move it, and you'll want to move it somewhere in those spaces so that it's safe. Caveat here, and it's even worse than trying to figure out insurance laws around 50 states, because now we go down to a municipality level. I highly suggest, if you're going to work with these vehicles, be in contact with your fire department, with your zoning department, so that you know what is appropriate in your municipality, and also OSHA, and be aware of that as well. I would love to give you a single answer, but there is none. And believe me, when we went and looked at all of our dealers, it became a nightmare of, okay, how do we figure out what is the universal standard and answer? And the universal was by a municipality. So be aware of that, right? So you need that space in your shop to work, but then there are some other things that you really need to take into consideration. If you have an above ground lift, you need a minimum of 67 inches between the pylons, not just the arms, the pylons, because we're going to need to get a hydraulic table under the vehicle, get it up under the battery to receive it when it drops out of the vehicle. And the floor needs to be flat, because now you have probably a 1,000-pound cart with a close to 2,000-pound battery on it, and you're going to need to wheel it in and around out of the way. If it's an in-ground console, we were talking with Barry Dorn last week about that, you need minimum 67. We really feel it should be 70, but that was the measurements at the time, between the hydraulic lifts that come out of the ground. Again, flat. It can't have the little bump as some of them do. All stuff to consider when you're getting ready for lift capacity. It's got to be 8,000 pounds or greater. So there's a couple out there now that meet that criteria that are 10,000 pound vehicles. And I would say if you're dealing with some of the larger competitors with their pickup trucks and vehicles of that nature, certainly you want to get into that level. Here's a picture of our Ashburn facility and kind of giving you a spatial relationship. Our technical instructor and I took this battery out, and the mechanical part was the shortest part of all, right? Because he and I took two impact drivers with the appropriate size sockets on it, and we got the battery underneath and just went to town. 37 fasteners, batteries out of the car in less than 15 minutes. Perfect, right? Let me tell you about the 5.5 gallons of antifreeze that you have to get out of the system and lock off. So you need to consider your capacity for antifreeze and recycling of that if you need to do it. Purging the system. Once you put the battery back in before you bring it up in energy, you have to purge the system. And that can take quite a while to get 5.5 gallons in and get all the air out. So this is all time that you need to account for in your repair planning and expectation setting for the customers, but then also in your shop supplies. So you can see, I mean, it fit quite well. We had that scenario, and you just take and roll it around, no big deal. Something else to consider, again, mentioned it earlier, when you put the vehicle in a booth, is it going to be a complete repaint where it has to go in for over an hour to bake? That's going to be a problem. You'll need to add additional air movers and drying methods like IR to bring it to dry at a lower temperature. So again, stuff that you need to know. Answers there down to municipality, right? Because it depends on whether you're able to shoot waterborne or traditional paints, right? So something we can go there. And then we get into chargers. The level 1 charger, that's 110. That, well, if we put it on charge today at an empty charge, maybe sometime next week, we might be up to voltage, depending on the system. Level 2 charger, it's 9.6 kilowatts, a big jump, but that could take 8 to 12 hours, depending on the vehicle. And then level 3, significantly less, which then would be probably in the 6-hour range. And then you get into the superchargers of 150 and 300 volts. So I'll give you a little view. And I always bring this one up, not only in high voltage, but in ADAS and in just general understanding. This is the e-tron with the 12-volt system. And it looks very much like a human nervous system, if you stop and think about it. 12 volts controls pretty much everything else, your power windows, your entertainment system, on and on and on and on and on. So you need to maintain that. And we were talking before we got together here at the desk, and one of the things that we have our dealers understanding now is e-tron GT, GTRS, that has to be in the showroom on a 100 amp battery minder, right? There are 130s that we have available, but 100 amp will do it. And then that's for the 12 volt system. Then the vehicle also has to be high voltage into the showroom high voltage charger so that it maintains, because you can imagine people going in and out of the car all day long and playing with everything. There's a lot of voltage. 12 volt is what turns the switch on to charge the high voltage system. So keep that in mind as well. And with that, I think we're pretty much at the end.
Perfect.
Here's our e-tron GT.
Awesome. Well, that was a lot of great information. I know that we had a lot of folks that have been paying attention and asking questions, and we've got a couple more before we wrap up. First one is, are the first responders trained by Audi to disconnect the high voltage batteries?
We have,
High voltage systems.
yeah, that's a large capacity question. I would like to tell you yes. Unfortunately, no. We interact through NABC and everyone we possibly can to do that, but not something that we've done en masse.
I experienced the same when I was at the government Colorado last week, where they're saying that's their biggest concern, how to approach these electric vehicles. And this is a lot of, I learned so much about the infrastructure of a town. And when, for example, a traffic jam occurs and it's like 1 hour long 1 hour time, I learned that $1.5 million of revenue is what a city or a state loses. Then people can't work that time there. There are, for example, from 8 hours a day, they can only work 7 hours. Then they stand 1 hour in the traffic, and this is what they're calculating this. And this is really interesting. And they say there is an electric vehicle in a traffic in an accident, and the firefighters, the tow truck drivers coming to the scene, and they're like, oh, I don't know what to do. I'm not touching this. And this increases those times. So I learned really a hard way that there is a lot of need for training, especially for those folks that they know how to approach those vehicles. And I think this is our job to help out here and
Absolutely,
and support them. So yeah, it was interesting for me, really interesting learning curve last week.
We're all on notice, and you know what, if you're a shop owner or an insurer and have the opportunity, I highly suggest it. Through iCar and NABC are all great organizations to do that and help our first responders help us ultimately.
Yep. Perfect. Well, all right. Well, that'll wrap everything up for us here today. Thanks for joining us, everybody. If you would like to see a replay of this, you will be able to, in the very near future, you'll see a copy of this video on the iCar YouTube channel. and you'll be able to watch it there. But again, if there are any questions that you have that we haven't already answered, please send those into repairersrealm@i-car.com. And if it's a question that we need to get over to Mark, we will get that to him and see if we can get that question answered for you and get a response. Thanks for joining us.
Thanks, everyone.
Thank you, everyone.